In this video, we're going to demonstrate how an AI model can be used for identity verification. To do this, we're going to be creating our facial recognition AI model using Python and some of its associated libraries. So to get started, we first need to make sure that we have the necessary Python libraries installed. On my screen, I have a Windows PowerShell terminal running with a Python virtual environment. And so to install the libraries that we need, I'm going to use the command pip3 install, and we're going to install face recognition and hit enter. And in my case, I already have the face recognition library installed, but if you didn't have it, this command would install the library for you. So at this point, we're ready to start creating the Python script to do the facial recognition. So on my screen, I've opened up a Notepad++ window, which is where we're going to be creating the code for our Python script. And we've called our Python script faceauthenticator.py. So the way that this script is going to be set up to work is that it's going to take in a command line argument representing the image that we want to check, and it's going to compare that image against a known image already loaded in its library to see whether or not that image is a sufficient match to the image already in our library to allow authentication into our system. So first, let's import the face recognition library with the line import face recognition. And now we're going to set up the baseline image against which the user is trying to authenticate. And in terms of sourcing the images, we've used this labeled faces in the wild database, the URL for which can be seen at the top of my screen in the bar at https://vis-www.cs.umass.edu/lfw. And on this page, we can scroll down until we see Explore the Database. And if we click on W and we search for Wayne Gretzky, we can see the 4 images that we have available to us for Wayne Gretzky. Similarly, if we go back to the Explore the Database page and we click on M, we can search for Mario Lemieux, and we have the image of Mario Lemieux. So these are 2 hockey players that we're going to be using for our system test. So in this situation, we are going to assume that Wayne Gretzky is a user in the system, and only Wayne Gretzky's face should be allowed to authenticate to our system. And so we'll create a variable called Gretzky face, and we're going to set that equal to face recognition.loadImage file. And as an argument, we're going to pass it a string to the location of the Wayne Gretzky image. In this case, we have the Wayne Gretzky image stored in the same directory from which the script is going to be run, and it's called waynegretzky1.jpg. And so now we have the face that we're going to compare against when authenticating to our system. Now we need to encode that face image in order to use it within the library. So we're going to create Gretzky face encoding as a variable. And set it equal to face recognition.face encodings. And as an argument, we'll pass it the Gretzky face variable. And we want our Gretzky face encoding to be the first element in the returned list. Next, we need to load in the image that we're going to compare against this file. Since this image is going to be passed on the command line, we're going to grab it using sys.argv. So I'm going to go back up to the top and import another library underneath face recognition, and it's going to be import sys. And so now we're going to create a new variable called unknownFace, and we're going to set it equal to face recognition.loadImage file. And we're going to pass it sys.argv, and in brackets, the number 1, which will insert the first argument passed to our script. In a production system, you would want to do a lot more safety checks here before using the argument on the command line to directly load the image file. But for our purposes, this is going to work okay. And now we're going to encode the unknown face in the same way that we did previously. So we'll create a variable called unknown face encoding. and set it equal to face recognition.face encodings. And we'll pass it the unknown face variable. And once again, we want to get the first element in the list. Now we are going to calculate the distance between the two images, which is going to represent how similar the images are. And to do that, we'll create a variable called face distance and set it equal to face recognition.face distance. And then the first argument to this function is going to be a list of the known encodings. In this case, we only have one, the Gretzky face encoding. And the second argument will be the face that we want to compare against, in this case, unknown face encoding. And now at this point, we are going to need to establish the face distance at which we would want to cut off authenticating versus denying authentication. So let's start out by just printing out this face distance and seeing what kind of values we get with different images fed into the system. And so I've just added a print statement to print that face distance variable out to give us a little bit of information about what we're going to be seeing. So I'm going to return to my Windows PowerShell terminal, and I'm going to run this new Python script using the command python faceauthenticator.py, and as an argument, I'm going to pass it a second image of Wayne Gretzky that's different than the first, and that's called WayneGretzky2.jpg. And then I'm going to hit enter, and it output the face distance between the two images, which is 0.37828.725. And for reference, here are the two images that we compared, with Wayne Gretzky 1, our base image, being on the left, and Wayne Gretzky 2, the image in which we were testing, on the right. Now let's try it again, but in this case, we're going to be comparing the image of Mario Lemieux to our library image of Wayne Gretzky. And that image of Mario Lemieux is on the screen on the right. And we'll see what kind of face distance we get with this image. So I'm going to use the same command, python faceauthenticator.py, but I'm going to pass it the image of Mario Lemieux instead. And it has output a face distance of 0.65755654. So what we can see is that the more similar a face image is, the lower that face distance is going to be. So we need to establish a cutoff somewhere in terms of where that authentication is going to allow authentication versus deny authentication. And it seems like a good value is 0.6. So I'm going to return to our script, and I'm going to delete this print statement. And now I'm going to add a conditional. And that conditional is going to say if face distance is less than 0.6, we're going to print out authentication allowed. And this is where in a production system, if this check passed, you would grant the user an authentication token or somehow allow the user into your system. Then I'm going to add an else statement. And if the face distance is not less than 0.6, I'm going to print out authentication denied. So now let's return to our terminal and try these commands again. So I'm going to rerun the first command with the Wayne Gretzky 2 image, and it prints out that authentication has been allowed. Next, I'm going to try the Mario Lemieux image again, and we can see that authentication has been denied. Let's try it again with the third Wayne Gretzky image, which we haven't tried yet in our system. And that one's called WayneGretzky3.jpg. And that authentication has been allowed as well. And once again, for reference, here is the Wayne Gretzky library image that we're using on the left, and here is Wayne Gretzky 3, the third image that we just tried, on the right. So this is one way in which we can use AI models to perform identity verification. In this video, we're going to look at a comparison of an AI-powered identity verification method versus a more traditional identity verification method. And then we'll also take a look at how they can be used to complement each other. So for our AI-powered identity verification method, we're going to be using the face authenticator script that we created in the previous video. As a quick recap, this face authenticator script works by storing a known face into its library, in this case a picture of Wayne Gretzky's face, and then comparing that library face with a face that's passed in as a command line argument to the script, representing a user trying to authenticate into the system. If the distance between the faces is less than 0.6, the authentication will be allowed, and otherwise the authentication will be denied. And as a refresher, to see this AI-powered identity verification method in action, we can call Python faceauthenticator.py and pass in a picture of Wayne Gretzky to the script, and it returns to us that authentication is allowed. Similarly, we could pass in a picture of Mario Lemieux, and our authentication is denied. So this is an AI-powered identity verification method. We are using a trained model to recognize and detect features of a known face, and then using that same AI model to detect and recognize features of an unknown face and compare the two in order to get a similarity metric. Now, let's create a new Python script that will represent a more traditional identity verification method, in this case, a username and password. So I've opened up a Notepad++ window, and in this window, we're going to create a simple script that uses a username and password to check whether or not a user is authenticated to a system. Now, as with the previous video, this is going to be a proof of concept system, so it's going to use hard-coded credentials to check against, and it's going to be lacking a lot of crucial safety and robustness features, and would not be a suitable way to implement this authentication in a production system. So with that in mind, let's get started with creating the script. We'll start by hard-coding a username and password into our system. So first, I define a username variable, and I set it equal to the string w_Gretzky. And then I create a password variable, and I set it equal to password1. These are the credentials that we'll be checking when a user authenticates into the system. As with Face Authenticator, we're going to be using command line arguments, so we're going to need the sys library. So at the top of this script, I'm going to import sys. We'll set it up so that the first argument is the username, and the second argument is the password that the user has entered. So I set a variable called entered username equal to sys.argv at the index of 1, which will get the first argument passed to the script. And then I create another variable called entered password, and I set that equal to sys.argv at the index of 2, which will get the second argument passed into the script. Now we can create a conditional to say if entered username equals the username in our hard-coded script, and entered password equals the password associated with that username, authentication will be granted, and otherwise authentication will be denied. So I type if username equals entered username and password equals entered password, we print authentication successful, else we'll print authentication denied. So now let's see this traditional script in action. We use the command Python, and now we call the new script, which is called traditionalauthenticator.py, and we're going to pass it w_Gretzky and password1. And when I hit enter, it tells me authentication was successful because the username and password matched. However, if I changed one of them to not match, for example, I give it w_Gretzky and password2, it tells me authentication denied. This is the traditional authentication method that many of us are very familiar with. So let's summarize some of the comparisons between our AI-powered facial recognition authenticator and our more traditional password-based authenticator. With our password-based authenticator, there's no intelligence behind the system. We are comparing a given set of credentials to a stored set of credentials, and if those credentials match, then we allow access, and if they don't, we deny access. In terms of weaknesses with this system, we have a few vulnerabilities or weaknesses that can occur. First, this type of setup is reliant on users making secure passwords and not having those passwords be compromised. So if our users create weak passwords like password1, then it is very easy for a malicious actor to break into their account and perform harmful actions. Similarly, if a user does not practice good password hygiene, for example, they reuse their password across multiple websites, then it's more likely for that password to become compromised, and once one account is compromised, all the other accounts using the same password are also compromised. With the AI-powered facial recognition system, we don't have those same vulnerabilities. We're not reliant on the user creating a password to set the level of security. The user doesn't need to remember anything, they just need to register their face so that the AI model can then use it as a comparison basis. So it takes the onus off of the end user to set the level of security with their authentication and puts the onus on the AI model to set the level of security. This doesn't mean that the facial authentication system is immune to all vulnerabilities or weaknesses, but it changes whose responsibility it is to provide the security, and it's far preferable to put the responsibility of establishing security into the hands of experts. With all of that said, these two systems do not need to be exclusive. We can actually use them together to complement each other and add multiple layers of security on top of each other in order to mitigate the weaknesses of both and maximize the strengths of both. This is the idea behind multi-factor authentication, and combining traditional security and authentication methods with AI-powered ones is a very powerful combination to bring forward. So to see this in action, let's combine this traditional authentication script that we just created with the facial recognition script that we created in the previous video. So I'm going to copy all of this code, and then I'm going to change tabs to our facial authentication script, and before the final conditional, I'm going to paste in the traditional authentication script that we just created. And so now, in our script, we have the code for the facial recognition and the code for the traditional authentication, and then at the bottom of the script, we have the two conditionals used for each script. At this point, we're going to combine the conditionals into one conditional, so I'm going to copy the logic of if username is equal to entered username and password is equal to entered password, and combine it into the face distance less than 0.6 conditional. So now our ending conditional reads like if the facial distance is less than 0.6 and both the username and password that has been entered equal the username and password in our database, we will allow access. If any of these conditions fail, we will deny access. So we are now relying on both facial recognition and password authentication to create our multi-factor authentication system. We also need to do one more modification and change the index for the entered username to be 2 and the entered password to be 3. This is because our first argument is going to be the image, which we use to authenticate, and our second and third arguments will now be the username and password. So now we can run our enhanced multi-factor authentication system with the command python face authenticator, and we're going to pass it the picture of Wayne Gretzky, 3, followed by the username W_Gretzky and the password password1. And the output is that authentication is allowed. Now let's try it again with the password of password2. And in this case, authentication has been denied. Finally, let's try it with the correct username and password, but we're going to change the picture to Mario Lemieux's picture. So in this case, we can pretend like the username and password has been compromised, but the attacker still needs to use their face to authenticate to the system. And in this case, even though the username and password has been compromised and the attacker has the correct credentials, the authentication has been denied because their facial recognition does not match. So this represents a comparison between the two systems and shows how they can work together. In this video, we're going to use AI to detect potential identity threats. To do this, we're going to use the same facial recognition identity verification system that we created in the previous videos. As a quick recap, this system works by learning a known face and then comparing any entered faces by the username against that known face and checking for similarity metrics to determine whether or not the face is a close enough match to allow authentication. We then augmented this system to implement a multi-factor method by combining it with a username and password authentication system so that any user needs to both have the correct face and the correct credentials to access the system. So now we're going to once again build up this same system by incorporating an AI alert system when it detects a potential threat. For the purposes of this demonstration, we're going to set up a scenario. And our scenario is that we have obtained threat intelligence telling us that there are malicious actors trying to access our system, and they are likely going to be using pictures of known celebrities to try and bypass our facial recognition system. And our threat intelligence goes even further to tell us that specifically they use pictures of Serena Williams, the famous tennis player, to try and bypass facial recognition systems. With this threat intel in hand, we are going to incorporate an alert system into our facial authentication identity verification method to raise an alert to our security analysts whenever we detect that something matching our threat intelligence report has been entered into our system. So first, I'm going to consolidate the existing code that we've already created a little bit by removing the white space between the lines. And now I'm going to add a new code block which will represent our AI-powered threat detection block. So given that our threat intelligence tells us that malicious actors are trying to use Serena Williams' face to bypass our system, we are going to encode Serena Williams' face into our AI model. So I'll create a variable called Williams face, and I'm going to set it equal to face recognition.load image file. And I'm going to pass it the path to the picture of Serena Williams, which is in the same directory as this script, and it's serenawilliams1.jpg. And then I'm going to create an encoding of that variable and call it Williams face encoding, and set that equal to face recognition.face encodings. And I'll pass it Williams face. And I want the first index in that list. Now we are going to compare any face that's input into our system against this known Serena Williams face to detect whether or not a malicious actor might be trying to bypass our facial recognition system. So I'll make a new variable called threat_intel_result, and I'm going to set it equal to face recognition.compare faces. And the first argument I'm going to give this function is the list of faces to compare against. In this case, we only have one, which is the Williams face encoding. And the second argument will be the face that has been passed in by the user, in this case, unknown face encoding. Now, threat intel result will be an array containing the results of whether or not the AI model has detected that the entered face is the face of Serena Williams or not. And so I can check if threat intel result at 0, then we'll raise an alert. And in this case, if the threat intelligence result is true, we're going to exit the Python script and raise an alert saying potential attack as per threat intelligence. So now we'll return to our PowerShell terminal and try this out. We'll start with a successful authentication once again by calling Python faceauthenticator.py, passing it the picture of Wayne Gretzky, the username of W_Gretzky, and the password of password1. And our authentication is allowed. Now, let's try passing it our picture of Serena Williams to see how our threat intelligence handles that case. And, as we can see in the output, it tells us potential attack as per threat intelligence. And in this case, our AI model has detected a potential threat, it has exited the system, it has not allowed authentication, and it has raised an alert to our security analyst. So this is an example of how AI can be used to prevent identity theft and protect our systems. Now, in this case, we built our threat intelligence off of a very specific scenario that we built up. In reality, you would not train your AI-powered threat intelligence to focus on just one face and raise an alert based on that. Rather, you would have a huge database of things like known celebrity faces and AI-generated faces and other things that would raise red flags and alert based on that rather than a statically hard-coded face. This would give you a much more effective alert system, but the overall principle is still the same. We want to build up a database of anything that is indicative of a threat to us, and we can get that threat intelligence report from a variety of different sources and use that to continually train and build up our AI model to have the best alerting system that we possibly can. And it's important that we incorporate any new tactics, techniques, and procedures that we learn that are being used by malicious actors into our AI model as we learn them.